We're in Rosen, Discrete Mathematics and its Applications, section 12.4 on circuit minimization. And we are looking at examples of four-variable K-maps. In this first example, we'll be looking at Boolean expression A, and we'll be putting it into this four-variable K-map. Remember, it can wrap vertically and horizontally for doing groupings. And I'll start to fill in the ones. W, X, Y, Z will go here. W, X, Y, Z bar will go here. And W, X, Y bar, Z bar will go here. And then W, X bar, Y, Z will go here. And W, X bar, Y bar, Z will go here. W, X bar, Y bar, Z bar will go here. And then W bar X bar Y, W bar X, Y bar Z will go here. And then W bar X bar Y Z will go here, and W bar X bar Y Z bar will go here. All right, so that's all of our ones in our table. We want to find groupings of power of 2 size as large as possible to cover these. Well, it turns out no groupings of size 4 are apparent. We can't twist them around, but there are groupings of size 2 that we can use to cover all of these ones, with one grouping of size 1 here on the bottom right. All right, and from this we can write down the minimized circuit. We'll start with this lower left grouping of size 2. That's going to be W bar, X bar, Y are the literals that don't change complementation. This going clockwise, we're going to have W doesn't change, and then Y, Z doesn't change. And we'll do this top one here. It's going to be W, X, and Z bar don't change their complementation. And continuing around clockwise, we have this covering of size 2. It'll be W, X bar, Y bar. Those don't change complementation. And then finally, our covering of size 1 will just be the minterm that generated it. And that'll be W bar X, Y bar Z. All right, now let's do the second example, B. And WX, Y bar, Z bar will go here. WX bar, YZ will go here. WX bar, YZ bar will go here. And WX bar, Y bar, Z bar will go here. W bar X, YZ bar will go here. W bar X bar, Y, Z bar goes here. And everything complemented goes there. All right, so now I see some coverings of size 4. Here's a nice one right in the middle. Then we have a elongated covering of size 4 right there. And we could cover this last one with a covering of size 1, but remember we want to use the largest one possible, and overlapping doesn't matter, so we'll cover it with one of size 2. All right, so let's write down the minimized function for this. We'll do the elongated one first, and that's going to be Y bar, Z bar. Complementations don't change for that. So it's all in the same column. For the middle grouping of size 4, X bar doesn't change and Z bar doesn't change. So X bar, Z bar. And then this grouping of size 2 will be WX bar, and then Y. WX bar and Y. And that's a nice minimization of that sum of products in B. All right, let's look at the last one, C. And see Wx, y, z bar, Wx, y bar, z bar, uh, Wx bar, yz, Wx bar, yz bar, and Wx bar, y bar, z bar. And then W bar xy, W bar xy z bar, W bar x y bar z bar, W bar x bar y bar z, then W bar x bar y z bar, and W bar x bar y bar z bar right there. All right, that's all of the min terms. And remember, we're looking for groupings with powers of 2 as large as possible. I see one that's size 8 here, so 2 to the 3rd power sized grouping right there in the middle. And then I see a grouping of size 4 at the bottom. We could have done it with 2, but if you can do it with 4, you should. It gets a smaller term. And then, as before, this 1 will capture with this one that's already covered to get a smaller term. All right, so for the largest grouping, what doesn't change? Only z bar doesn't change. So z bar for that grouping. For this grouping, elongated grouping of size 4 along the bottom, W bar X doesn't change complementation. And then for this covering of size 2, as before, it's Wx bar Y, which is another nice minimization of that rather large sum of products. And that's some examples of 4 variable K-maps.